Hello guys, welcome back to my channel. We are still continuing with the layout and we are in the pastry preparation area. We did the wood, we did the oven stand, we did this pastry table and the hand wash basin. Today we are going to be doing PP1A, which is a 2-tier over shelf. Right, it's a very simple drawing. We are going to deal with that, and if I could pull, yeah, this is a 2-tier wall shelf, 2-tier wall mounted shelf. This is the top tier, this is the mid tier, this is the lower shelf. Right, there is a tubular structure here for giving it strength, and also it will help in the mounting. These are the mounting brackets with 3 holes of dia 10mm because you intend to use row bolt of M8. Right, now this is the drawing. The wall shelf, ideally it should be 2 meter because the pastry preparation table was 1500 and the hand wash basin is 500, so that is 2 meter. So the length we are going to keep it at 2 meter. The depth is 300, as you can see here, and the difference from the lower part to the upper shelf is 350. There is an upstand of 25mm. There is also an upstand in the lower shelf, this of 25. Then there is a bend of 15mm and another one going down of 10mm. This bend right here is 25 because we intend to this square tube. You can use a square hollow section tube of 25 by 25. Ideally you should use 25 by 25, but as usual I don't have that in my ISO weldments. I have 30 by 30 and 20 by 20, so I keep this 25. I will use what I have in my weldments, right? So if I could pull the, yes, see the arrangement. This is the granite pastry preparation table and the wall, the hand wash basin, and as you can see, this is my wall shelf. Actually it should be all the way up to, it should cover both the pastry preparation table and the hand wash basin, so that you might have more storage. The idea of having wall shelves is to create more storage. Okay, so it's a very simple drawing. Sheet metal for the shelves and weldments for the structure. So let us go ahead and open our SolidWorks and get right into it. Yeah, new part. Go to top plane, sketch, center rectangle, snap it from the origin. This would make it 2 meter, and this should be 275 because of the 15mm bend that I have shown you. Click OK, sheet metal, base flange. The thickness of the material to be used is 1.2. 1.2 material should be ideal for a wall shelf. There is no harm there. We are not going to change the other parameters, so you click OK or right click. Yes, that should be about it. So we create an edge flange here of, that is the upstand of 25mm. Like I have said, this is a very simple drawing. You don't need to worry much about it. Edge flange all the way round off. Since we are using a tubular structure of 20 by 20, we can make this, at least to give it some small clearance, we use 22 millimeter, but it should be 30. Let us work with 30, so we make this 32, so that the bend might not also appear very small. Okay, and there is the edge flange of 15 millimeter as usual to avoid sharp edge. Going down here, 15, and that one, and also we can combine it with this edge flange here, 15. Click OK. Then finally edge flange going downwards. That edge flange is always, that small bend is always important, because there will this part lies against the wall and it will always be neat, right? Here it will always be neat. Want a continuous surface which there is no gap between the wall and the wall shelve. So go ahead and save. Projects, SolidWorks. We are in we create a new folder, call it PP1A. Then open the folder and save this as part number 1, PP1A. Top shelf and bottom shelf, is there any difference? There is no difference, so we call it shelve. Right, that should be about it. Now let us try to see where is our evaluate measure. From here, want to get the normal distance to here. Normal distance is 292. Okay, so go to file, new part. Now we are creating we will be creating the tubular structure. Right plane, new sketch. It should be something like that. This and this should be equal. Sorry, this line and this line equal. Then we snap this to the origin, that and that, to make them coincident. That should be it. This and this should be right around, because we want 350 minus 30 minus 30, that is 320, and this is 275. 272 minus 15. 272 minus 15. We will confirm. I keep telling you, the beauty of SolidWorks is that you can always go back to the sketch and edit it if you feel like it is not agreeing with what you want to fabricate. So go to weldments, structural member, and you choose your ISO square tube configuration. You choose square tube of 30 by 30. I still don't like the thickness. You can use thickness of 1.2 or 1.5. The parameters that SolidWorks is giving me, I'm not happy about it, and I think it is high time I sort it out. If there is any add-ons that I need to incorporate in my SolidWorks, I will go ahead and take a look about go ahead and solve it out. Okay, now the group, as you have seen, I'm sure most of you from our previous drawings, they are aware how we go about our weldments. Okay, now the sketch, hide the sketch. Okay, and that should be about it. Save it as part number 2, PP1A, structure. The T should be small. Is that how we write structure? That is it. Okay, so let us go ahead and open new folder, new file, and go right into assembly. Assembly, the base part is the shelve. Insert tubular structure, met. The top of the tube should be against the bottom part of the shelve, and this face to that face, click OK. Then this face to this face, because it will be lying against the wall. There should be a small notch somewhere. There should be a notch. Don't know how much. Let's exit this. Now let me open this part and try to get from here, evaluate from here to here. What is the normal distance there? The normal distance is 18 and we need 30. 18, so we notch it at 12. So go to this edge flange, sketch number, sketch, that sketch, edit the sketch, create a line between this parallel to the other line, make this construction line, dimension from this to this, let's do it 13 mil, then trim. That's okay. Exit the sketch. We have created that notch. Same thing on the other side. This should be sketch number 20. This should be which sketch? Sketch number? Not 29, 28. Edit sketch. Something that we have done to the other side, we do to this side also. A line that is parallel to that. It's okay, we are going to trim it later. Between this and this, 13 millimeter. 13, then we make this this we make it construction, and we trim. First we trim this, and we trim the two lines. Exit sketch. That is nice let us go back to our assembly, save the changes. We go to our assembly, accept changes. Yes, see, it's not touching. 13 looks big. Well, these are the notches that you make as you do the fabrication. It's not necessary while you are doing the DXF you do the notch. No. Just do the shelf as we have done it without this notch. Then once you put your tubular structure in place, that is when you can notch this part, right? Because you don't want any gap. You are going to do your welding here. Your welding should be right here. Try much as you can to avoid welding here. Okay, so that's about that. Let's see whether if we mirror this part, it will be in agreement with what we're looking for. Right plane of the shelf, mirror components, component to mirror is this part here. That's not right. Delete. We delete the mirrored component because, as you can see, the back part has come to our front part, and don't want to think of ways of rotating. Why can't I just insert another component, and do the assembly? Met this face to this face, this to this, right click or click OK, and the bottom part, the bottom face, and this other face, right click, exit met. Yes, that's good. Now I might want to do a linear pattern so that I may create the lower shelf, but let me just do the lower shelf because it has a notch someplace and I don't want to. So this is PP1A wall shelf. So let me go and do new sketch, that is new part, top sketch, center rectangle, 2 meter. I keep saying that there are so many different ways of going about this. You don't necessarily have to create another shelf, but for the people who are trying to learn SolidWorks, it is always good for you to do as many parts, even if they are repeating themselves. Do as many as you can. That is how you will master these things. No much difference between this shelf and the previous one. Everything remains 25. The only difference right now is that we will edit this sketch, create a line here and create a parallel line to the edge of the this line is not vertical. Make it vertical and make it construction line so that we may mirror this line, mirror entity, mirror about the construction line. Okay, that's about it. This line, and this line we make them construction lines. Then we measure the, dimension it and give it 30.5. 30.5. That's good. Also this other side 30.5. What's going on here? Yeah, the same because we mirrored. Okay, so with that done, we trim this line. Why are they conflicting? And we trim this. Yeah, Sketch can now find a solution. Exit. Yes, that's good. And create the edge flanges. The other edge flange we created was 32. Then the 15mm edge flange going inside. This we are not going to notch. I'm sure you know why we have notched the other one and why we are not notching this one. You don't need to notch this. This is 15mm. Then an edge flange at the back of 10mm. And condition blind 10mm. Yeah, you can save this as part number 3 and call it EP1A lower shelf. Yes, as I was saying, different ways of doing these things. Yeah, it's a shortcut here and there. You could take the first shelf and introduce this notch, save it as save as. Okay, go back to the assembly and insert component. To insert is the lower shelf. Met component. This face and this face are always parallel. This and this. Right click. Then let me see. This bottom face, this face, and this face. Yes. See why we did do the notch here? Because look at where the square tube is passing through. Yeah, it's 30mm, 32 is good. And there is that 30mm that we did there. Okay, so that looks about it. Something is not right. This edge flange, we did it as 15mm. The square tube, yeah, I have seen it. This edge flange, in fact, even with the top part, the edge flange, this edge flange should be about 30, so that this bend comes right here. So we need to open this and edit this sketch. Base flange, we edit. It is 375 minus 15 minus 15. This should be, we subtract 15 here. 15mm. 360, 260, sorry. That's okay. Then we make this edge flange, we edit. Let us edit. I shouldn't have done that. Is it? No, not the fourth, but the third edge flange. We go to this sketch, edit. From here to here, 15, make it 30. Yes. Let us see whether those changes up there will agree with the changes in us. Give us the solution. Yes, yes, yes. See, the square tube is not, you don't need to do a notch here, and here it will look a bit neat, yeah, though it is not very economical, this 30 millimeter. That is why I was saying ideally this square tube should be 25 millimeter, right? 25 millimeter should be ideal. Yeah, I think our whole shelf is done. The only remaining thing, let us evaluate first and see the difference between with that and this. Normal distance is 290. So if you create a new part, number 2, we go to front plane. We want to create the mounting bracket. 30 millimeter should be good, and the height should be 280. Thickness, sheet metal thickness of that. What's going on? Yeah, base flange thickness of the material should be 2 millimeter, because this is the one that will be carrying weight. Let us do the holes. Sketch normal. We have our circle there, another one there, and another one there. Select all of them and make them equal. Then smart dimension, diameter 10. Raw bolt of 8 millimeter should be very much ideal this job. Make it 30 millimeter from the bottom. The other one we snapped it at the origin, so that one don't need to change anything. This also is 30 millimeter. Then we extrude and cut. Link to thickness. That's good. There you have your holes. Go ahead and save mess part number 4. PP1A. Sorry, 1A. Mounting bracket. Mounting bracket. We go to our assembly and insert component. Component to insert is the mounting bracket. Met this back part should flush with this face. That's okay. This edge flashes with this face. That is where you will do your welding. Here you'll do your welding. Then the bottom part, the bottom face, sits right on top of this face. Welding here and stitch welded stitch welds here. Yeah, if you want, why don't we do this? Let us evaluate. But if we do that, I think that is good. That is good. We go back to the right plane and mirror the mirror components. Component to mirror is that mounting bracket. This, right click. Yeah, and your wall shelf is good. Your wall shelf is good. The only thing after doing the fabrication, you take it to the site, you trace the holes, make sure it is leveled, and like we said in our layout, explained the height from the ground to the first shelf is most of the time 1500. Okay, when you are doing the mounting, 1500 from the floor to this face, 1500. So wall shelf is always not an hard drawing to do. Even the fabrication is always very simple. Mounting, very simple. Now, one thing I should mention right here is some clients may prefer to have this like a tray type, right? So this hedge flange and the other one on this other side, instead of them going towards the lower direction, they go to the upper side. Yeah, so it forms like a tray, right? Like a tray. But this is just for storage, maybe your cutlery, you know. It's not like you're going to be storing, I don't know, but whatever the preference, that is the only difference. And most of the time, standard size of a wall shelf is 1500. You don't want to have a wall shelf which is protruding, which is like 500. That cantilever, mounting that cantilever of 500 from the wall will be a big issue, right? You know, see where we are mounting it. Then you are having this as 500. If you place heavy stuff on this, close to this edge, yeah, bending moments and all that, you remember, right? So thanks so much. I don't know, let me see what our next drawing will be. Yeah, there are some low boy trolleys. Did we do low boy? Yes, we did this. These are heavy duty trolleys, so we have some low boy trolleys, two of them that are stuck right under the pastry preparation table. But I also feel like there should be a tall boy trolley someplace. Yeah, for if you're baking, say, some breads, how are you going to be cooling them? So you need a tall boy trolley. So our next drawing, we are going to do a low boy trolley, probably together with a tall boy trolley. We'll see about that. Okay, so there you go. You have your wall shelf. All you need to do is save these parts as DXF, export them, go do nesting, cut them with your CNC. If you don't have a CNC machine, you get the cutting, the flat pattern cutting sizes and the marking sizes and all that, and do the fabrication. Let us make our commercial kitchen guys happy. Okay, yeah, and all the materials stainless steel 201 wood, grade 201. That's good. I said thanks so much for your time. Hope we meet in our next video.